All right, we're going to now talk about the distributive property. All right, and there's really no definitions to write down, so we're just going to go right through it and give an example, and I'll show you how it works. All right, you can find the total area of these two rectangles by two methods. Okay, supposing you had two rectangles and you had to find the total area. Well, one way you could do it is you could find the area of each one. That would be, you know, the area's length times width, so it's 4 times 3, plus the 4 times 5. Okay, 4 times 3 plus 4 times 5. Or you could just go ahead and shove it over a little bit and make one big rectangle. And this time you'd have 4, the length, times the width, which would be the 3 plus 5. So you'd have 4 times 3 plus 5. You'd have this 4 and then this whole 3 plus 5. All right, so this would be an example of the distributive property, because you would see that the areas would both have to be the same number, because they're both just the exact same thing. This rectangle plus that rectangle. So they have to be equal. So this one right here, the way to express it here, would have to equal the way we expressed it here. And that's an example of the distributive property. All right, we did 4 times the 3 plus 4 times the 5. All right, now here's how it actually works. Let me show you. If we were to actually just use letters for all the numbers, okay, use variables, it would be, supposing we had some number, and then we did parentheses b plus c. Well, that's going to equal a times the b. And what I always like to do is have you draw arrows, a to b, and then a to c, to make sure that you distributed the a to the b and distributed the a to the c. So it's a times b plus a times c. All right. Now, because with multiplication we can switch things around because of commutative property, I could put the a at the back of that, below it. I mean on the end of it, and I would still do the same thing. You still would distribute the a to the b, being b times a, and then you distribute the a to the c, which would be plus c times a. All right. So we're going to do some examples. I think it'll be more clear. You can think of the distributive property as a shortcut. All right. You are distributing the number on the outside to each term on the inside of the parentheses. That's really what you're doing. You're distributing. That's why it's called the distributive property, because you're distributing that number on the outside to everybody on the inside. All right, now you're going to say to yourself, well, we just learned about order of operations. Why don't we just add, like in this example, the 5 plus 9, and then multiply it by 3? And you could do that. The times that you would use the distributive property for sure would be when you had variables inside of the parentheses. Okay, but I'll just show you a simple example without the variable, just to kind of get the idea. But you're right, you could use the order of operations, just do 5 plus 9 is 14, and then times 3, and you get 42. All right, but let's just do it with the distributive property just to kind of show an easy example. So I draw my arrows, 3 to the 5 and 3 to the 9, and I say to myself, 3 times, remember that's just all times, right? 3 times 5 plus, just copy the plus sign, 3 times 9, okay? Because this really means 3 of these. You're really just going 5 plus 9 plus 5 plus 9 plus 5 plus 9. So it is a shortcut, because instead of writing all that out, I'm just doing 3 times it, okay? All right, so another example now. So the answer ends up being, that's going to be 15, that's going to be plus 27, which equals 42. Okay, so now let's do one where we have to use the distributive property. We can't do the order of operations. All right, so I draw my arrows. I do 4 times the 3x, and then 4 times the 6. And then this time I have a plus 7x, an extra little thing in there. All right, so we get to use our combining like terms as well. So I do 4 times 3x plus 4 times 6 plus the 7x. Okay, I'm going to go ahead and circle my like terms. Okay, I know that's 12, so I could just put 12x here. That's fine. So 12x plus 7x is 19x, and then plus 4 times 6 is the only one of them there, plus the 24. And usually you put your x terms first and then your constants at the end. So that would be the simplification of that. All right, here's another one. You got 6m plus 14 plus all that. So again, I can't do order of operations because I can't add those two together because they're not like terms, right? So I got to use my arrows. Okay, I'm going to go ahead and copy down my 6m plus the 14 plus 3 times 2 is 6m plus, I write down my plus sign, 3 times 7 is 21. Then I combine my like terms, 6m plus 6m is 12m, and then I box out the plus 14 plus 21, and that's plus 35. So that'd be your answer, your simplification for that. All right, so I'll go through another couple examples, and then that'll be it. Okay, sometimes you're going to have a negative in the front. We haven't really talked much about negative numbers, but we will, so I thought I'd just at least go ahead and show the distributive property with the negatives. So again, you draw your arrows. All right, so I think negative 2 times x is negative 2x. Write down the plus sign, and then negative 2 times 4, we're going to learn later, is going to be negative 8. Okay, but again, it's the same thing, and that would be your answer. You can't do anything else with that. Okay, we're not solving for x because there's no equal sign. Just that equal sign just is the equivalent expression for it, not solving it. Okay, so here again, I can't do that because they're unlike terms, so I draw my arrows. I do 5 times x, 5x. I write down my minus sign. And I do 5 times 9 is 45. And again, that would be the simplification for that, or that would be the distributive property of that. Okay, now here I have a negative 3, so I draw my arrows. Negative 3 times x is negative 3x. I draw write down the minus sign, and I do negative 3 times 6, negative 3 times 2, which we're going to learn is negative 6. Okay, then later we're going to learn how to take care of those two negatives, but for right now you can leave it like that. Okay, so let's do some a little bit more complicated ones, and this time they want you to simplify it and then evaluate it given this number. Like if x equals 4, we plug the 4 back into the x. So here I started this. I didn't draw my arrows, which I should have done. Okay, then I got 3x plus the 10x minus the 30. Okay, so I'm going to combine my like terms. 3x plus 10x is 13x minus 30. Now I've got to plug in 4 where the x is. So that's going to mean 13 times 4 plus 30. Okay, so 13 times 4 is going to be 52. Think about a deck of cards. There's there's 13 cards for each suit. There's 4 suits, okay? And there's 52 cards in a deck if you guys play cards. Okay, plus 30. Okay, so 52 plus 30 is 82. Okay? This one's the same kind of thing. Again, I draw my arrows. Okay, 4 times 2 is 8m plus 2 times 5 is 10 plus 8 times 3. 8 times 3 is 24m plus 8 times 1 is 8. Now, m is going to be 3, but I'm not going to use that until the very end when I just have 1m. So I'm going to go ahead and combine my like terms, box up the other guys. 8 plus 24 is 32m, plus 10 times 8 is 18. My m is 3, so I do 32 times 3. It's going to be 96. So it's 96 plus 18, and if you need to do it over here, just do it on your piece of scrap paper. 96 plus 18, that's 14. That's going to be 11. It's going to be 114, and that's your final answer for that.